Hello everyone, welcome to the lecture of data science, and today we will cover different distribution functions and we will cover how to compute some of the statistics in these distribution functions. Now, to start with distribution function, let's see what are various distribution functions we are going to cover today. First is uniform distribution. Now, in uniform distribution, all outcomes are equally likely. Second is Bernoulli's distribution. There are only two outcomes in a Bernoulli's trial: success, often denoted as 1, and failure denoted as 0. Third is binomial distribution, deals with number of successes in a fixed number of independent Bernoulli's trials like coin flip. Next is Poisson distribution, useful for modeling the number of time an event occurs in a fixed interval of time or space. And last is geometric distribution, concerned with number of trials needed to get the first success in repeated independent Bernoulli's trials. Now, these are some of the basic distribution functions. Let's start with uniform distribution. Now, let's see the formula for mean and variance on the screen. The formula for mean or average in a uniform distribution is mean mu equal to sigma I equal to 1 to n xi divided by n, where xi represents each individual outcome and n is the total number of outcomes. You sum up all the possible outcomes xi, then you divide this sum by total number of these outcomes. The result is average value of outcomes. Next is variance formula for uniform distribution. The formula for variance in a uniform distribution is variance equal to sigma summation of xi minus mean whole square divided by n, where xi represents each individual outcome, mu is the mean of all outcomes, and n is the total number of outcomes. Now let's understand this using some of the examples. For example, rolling a fair dice. Outcomes: when you roll a fair 6-sided dice, there are 6 possible outcomes: 1, 2, 3, 4, 5 and 6. Now the mean calculation. The mean is found by adding all the outcomes together and divided by number of outcomes. So mean mu equal to sum of all the outcomes, which is 1 plus 2 plus 3 plus 4 plus 5 plus 6 divided by 6. And if we solve this equation, we will get 3.5. Now let's come to variance calculation. Variance measures how much the outcome differ from the mean. First, subtract the mean from each outcome, where the result, then average these squared differences. So variance equal to, what is the first value? First value is 1 minus what is mean 3.5 whole square plus second value 2 minus mean 3.5 whole square plus third value 3 minus mean 3.5 whole square, and so on till 6. If you solve this equation, you will get 2.92. So the variance in this example is 2.92. Let's understand another example. Drawing cards from a well-shuffled deck. For deck of 52 cards, there are 52 outcomes. 1, 2, 3, 4 till 52. Now, mean is all the value of the cards in the numerator, which is 1 plus 2 plus till 52 divided by 52 equal to 26.5. Final answer. Similarly, let's calculate the variance. Variance is first value of the card 1 minus mean, which is 26.5, which we have computed in previous step, whole square plus second value 2 minus mean to 26.5 whole square, and then divided by total number of cards, which is 52 here. So we will get 225.25 as variance. It shows the average of square differences from the mean. This is variance. Now let's take third example. Choosing a random number from 1 to 10. Outcomes are the numbers 1 through 10. Mean is computed as all the values. First of all, in the numerator, 1 plus 2 plus 3 plus till the 10 divided by total number of values, which is 10. If we solve this equation, we will get 5.5. Now, if we compute the mean of same problem, we will get first value, it is 1 minus the mean, which is 5.5 whole square, plus second value 2 minus 5.5, which is mean whole square, plus till the 10th value. If we solve this, we will get 8.25. Now, while understanding these examples, I want you guys to take pen and paper and solve these questions. It's very, very important. The next distribution we are going to understand is Bernoulli's distribution. The mean formula for Bernoulli's distribution, the mean or expected value of a Bernoulli's distribution is given by mean mu equal to p, where p is probability of success. Since there are only two outcomes, the mean is simply the probability of success outcome only. Now, variance formula for Bernoulli's distribution is variance equal to probability of success bracket 1 minus probability of success, where p is again probability of success. The variance is calculated by multiplying the probability of success by probability of failure. If probability of success is p, then probability of failure is 1 minus P. Understand the basics of probability. The sum of all probabilities will be equal to 1, right? This formula represents the expected deviation from the mean in a process that has only two outcomes. Now, let's understand a couple of examples with mean and variances in case of Bernoulli's distribution. First, flipping a coin. What is the success for getting heads? That is 0.5, right? There can be head or there can be tail. The probability of having head is actually 1 by 2, which is 0.5. So the mean is P itself, which is 0.5. The variance will be P multiplied by 1 minus P, so 0.5 multiplied by 1 minus 0.5, which is 0.25. Similarly, let's take an example of pass and fail test. Suppose there is a probability of passing a test which is 0.8. So the mean in this case is 0.8. The variance will be 0.8 multiplied by 1 minus 0.8. Again, P multiplied by 1 minus P, which is equal to 0.16. Third, light bulb functioning. Suppose let's take an example of light bulb. The probability that light bulb works is 0.95. So the mean here will be 0.95 and the variance will be 0.95 multiplied by 1 minus 0.95 equal to 0.0475. Now let's start with binomial distribution. The mean formula for binomial distribution is the mean or expected value of binomial distribution is given by mean mu equal to n multiplied by p, where n is number of trials and p is the probability of success on a single trial. The mean is the total number of trials multiplied by probability of success. It represents the expected number of successes in n trials. The variance formula is variance equal to n multiplied by p multiplied by 1 minus p, where again n is number of trials and p is the probability of success on a single trial. Now let's understand this using examples of binomial distribution. First is flipping 10 coins. You flip a coin 10 times and count the number of head or success. The probability of success P in each experiment is 0.5 and number of trials n equal to 10. So the mean will be n multiplied by P. So here 10 multiplied by 0.5, which is 5. The variance is n multiplied by P multiplied by 1 minus P equal to 10 multiplied by 0.5, 0.5 equal to 2.5, right? Let's take second example, making 15 free throws in basketball. So the situation here is a basket player makes 15 free throw attempt and we want to know the expected number of successful throws. Probability of making a free throw success in a single experiment or a single throw is 0.7 and number of attempts n equal to 15. So the mean calculation is equal to mu equal to n multiplied by p equal to 15 multiplied by 0.7 equal to 10.5. The variance is n multiplied by p multiplied by 1 minus p. If we put all the values here, we get 15 into 0.7 into 0.3, which is 3.15. Let's take another example. Consider quality control in manufacturing. This is a very practical example and sometimes industries and companies use it. Situation: in a factory, 100 products are inspected to identify defective ones. Probability of a product being defective, when we say defective, it means a success. Success not in literal terms, but success in terms of finding a defective product in the manufacturing chain. So product being defective, success equal to 0.02, assuming 2% of the products are defective. Number of products tested, n equal to 100. Mean is equal to n multiplied by p equal to 100 multiplied by 0.02, which is 2. The variance is equal to n multiplied by p multiplied by 1 minus p equal to 100 multiplied by 0.02 multiplied by 0.98 equal to 1.96. Now let's start with Poisson distribution. The mean formula for Poisson distribution is given by mean equal to lambda, where lambda is the average number of events in the given interval. The mean in Poisson distribution is simply the rate at which events happen. For example, if on average 2 emails arrive per hour, then lambda equal to 2. The variance formula is actually the same. Poisson distribution is a distribution where the formula for mean and the formula for variance are same. So the variance is equal to mean, variance is equal to lambda, where lambda is same average rate of event. Now let's understand this using some examples, right? Number 1, emails received per hour. On average, you receive 3 mail per hour. So average rate equal to 3 email per hour. Here mean mu or lambda equal to 3. Variance and mean are same. So variance lambda equal to 3. Second, customers arriving at a shop. A shop observes that on average 5 customers arrives every 30 minutes. So average rate is 5 customers per 30 minutes. Mean equal to lambda equal to 5. Variance lambda equal to 5. Let's take third example. Phone calls at a call center. A call center receives an average 10 calls every hour. So average rated 10 calls per hour. Mean is 10. Variance is 10. In each of these examples, the Poisson distribution is used to model the number of occurrences of an event in a fixed period of time. The distribution is particularly useful for the rare or random event. The equal mean and variance makes Poisson distribution unique and particularly suitable for these scenarios, providing a simple yet powerful way to understand likelihood of observing a certain number of events within a given frame of time. Now, next is geometric distribution. The mean or expected value of a geometric distribution is given by mean mu equal to 1 divided by p, where p is the probability of success on each trial. The mean represents the average number of trials required to get the first success. For example, if probability of success is 0.2, on average 5 trials, 1 divided by 0.2 are needed to get the first success. The variance formula is the variance of a geometric distribution is 1 minus p divided by p square. P is same, which is probability of success on each trial. The variance measures the expected variability in the number of trials required to achieve the first success. It's higher when probability of success is lower because mean equal to 1 by p, and the denominator you can see there is p square in variance. So it's higher when probability of success is lower, indicating a greater spread in number of trials needed. Let's understand this using some examples. First example is hitting a bullseye in archery. Probability of hitting a bullseye each time, probability is equal to 0.5, mean equal to 1 divided by 0.1 equal to 10 attempts. Variance here will be 1 minus 0.1 divided by 0.1 square equal to 90 attempts square. Getting a head in coin toss. Probability of getting a head or success on a coin toss, probability is equal to 0.5. Mean mu equal to 1 divided by 0.5 equal to 2 tosses. Variance will be 1 minus 0.5 divided by 0.5 square equal to 2 tosses square. Third example, catching a fish. Probability of catching a fish success each time, probability is equal to 0.2. So mean equal to 1 divided by 0.2 equal to 5 attempts. Variance will be 1 minus 0.2 divided by 0.2 equal to 20 attempts square. In these examples, the geometric distribution provides insight into scenarios where you are repeatedly trying for first success. The mean gives an idea of how many trials on average are needed for first success, and variance tells you about the spread or dispersion in the number of trials needed. The distribution is particularly useful in scenarios where probability of success is constant for each trial and trials are independent. So these are some of the distributions which I have explained using some examples, and in next lecture I will go more deeper into statistics and cover more topics. Please subscribe this channel and let's see in next lecture. Take care. Bye bye.